Welcome to the AI Applied podcast. I'm your host, Jaden Schaefer. Each week, I cover breaking AI news, tools, and interview experts giving you actionable tips on applying AI into your career, job, workflows, and life. Make sure that you go to aibox.ai, link in the show notes, to join the waitlist for our new AI platform. We're going to be launching an incredible platform that allows you to build anything you want with workflows in AI. So you're able to chain together ChatGPT and image generators and audio generators to make really powerful apps for your organization, or you can host them on our marketplace and actually generate royalties from them. So make sure to go to aibox.ai and join the waitlist. In addition, if you like the podcast, if you could do me a massive favor and please leave us a review on Apple or Spotify or wherever you listen to your podcast. This helps me be able to get better guests on here as they check the reviews to see how you guys are liking it. So if you could please do that, I would really appreciate it. There is a crazy new, slightly dystopian development in AI where they're essentially mixing AI chips with human brains. Now, this is something that sounds straight out of a sci-fi novel. So today on the podcast, we're going to break it down. We're going to be talking about what this technology does and also why the Department of Defense is backing this project. So essentially, this is the Monash University's neuroscience division, and they're introducing what they're calling dish brain. So it's essentially a semi-biological computer chip which was cultured with around 800,000 human and mouse brain cells. It apparently didn't take long for this silicone brain hybrid to showcase its potential, and learning to play the classic game of Pong in a mere 5 minutes. Which is, similar to what a normal human would be able to learn. So this thing is very interesting in how it actually works. So essentially a high-tech microelectrode array is acting as a conduit between the computer and the biological neurons. So by reading the neural activity and providing stimulatory electrical pulses, this array paved the way essentially for brain cells to actually interact with Pong and to let them control the paddle's lateral movements. So the setup was completed by a rudimentary reward system that took advantage of the cell cluster's inherent instinct to reduce unpredictability. And a predictable stimulus was provided every time the paddle successfully made contact with the ball. But a miss led to a brief 4-second window of, essentially pure chaos. So, yeah, and that was characterized by total unpredictable stimulation. So the experiment was the first of its kind, marking a pivotal moment where lab-grown neurons were actually given the tools to perceive and react to their surroundings. And the result, unsurprisingly, was, pretty impressive, the technology that was actually developed. Now, my opinion on this is still that this seems incredibly, it seems kind of dystopian. Like, let's be honest, using human brain cells and interfacing with computers. But this is still a very interesting technology, and being able to use that may not actually be as alarming as you think. These really are just lab-grown brain cells. So anyways, it's kind of interesting. I think with really impressive results like this, it's not really a surprise that the project was able to receive funding. So Monash University and the Melbourne-based startup, which are Cortical Labs, have now received a grant of over $407,000 from Australia's National Intelligence and Security Discovery Research Grants Program. So not America's Department of Defense. This is actually over in Australia. And, this is 407,000 Australian dollars. So according to project leads, Associate Professor Adzel Razi says that these programmable chips are an intriguing blend of biological computing and AI, and that they could be the path to actually outshine conventional silicone-based hardware in the future, which is really bold of a statement, right? He is betting that these things are going to be better than, classic silicone that we normally use. So the implications of such advancements are vast. They're really spanning from, planning and robotics to advanced automation, brain-machine interfaces, and drug discovery, and I think potentially would grant Australia a very strategic edge when it comes to this whole AI revolution that we're currently embarking on. So I think kind of looking through this and looking towards the future, Razi, who is working on this, really believes that DishBrain's advanced learning prowess could lay the foundation for a new wave of machine learning, and particularly this would be particularly relevant for autonomous vehicles, drones, and robotics. Essentially, it could infuse them with, a quote, new type of machine intelligence that is able to learn through its lifetime. And that's what Razi said. So, this is very interesting because essentially these chips are learning similar to how AI learns, but this is actual human brain cells that are being used. And this is pretty crazy to think that you're putting human brain cells and using them for chips. And I'd be curious to see if this is, going to be faster or slower than what you could do with typical silicone. Razi appears to think that this is going to be more advanced than silicone, so that's very interesting. I think the promise of this kind of technology is very intriguing, to say the least. Machines that continue to acquire new skills without letting the old ones rest, essentially. And also, you'd be creating machines that adapt effortlessly to change and map old knowledge to novel situations. So they're constantly optimizing their use of computing power, memory, and energy. Razi was pretty clear about the intended use of the grant. He said, quote, "We will be using this grant to develop better AI machines that replicate the learning capabilities of these biological neural networks. This will help us to scale the hardware and methods capability to a point where they become a viable replacement for in-silicon computing. So, in essence, I think the next big leap in AI might actually look closer to this than, something else in silicone that we might be coming out of. And I'd be really curious to see if, this technology gets developed, if this gets advanced, if they do licensing deals. I mean, think of how crazy that would be if NVIDIA came out with, human brain cells embedded into some of their chips and some of their technology that they were doing. It's really interesting because essentially, I think up until this point, technology really was developed in a way that they tried to imitate a brain and imitate how humans learn and how intelligence learns. And the closer we came to that imitation, the better our technology seemed to get, to a point where I've seen some really impressive breakthroughs by, instead of doing things how a traditional computer does them, people, researchers are like, well, we copied X, Y, and Z on how a mouse learns about something. We applied it to a machine, and then our AI algorithms improved. And now all of a sudden, it's really interesting because we're getting down to the hardware itself is now coming from humans. It's literally human brain cells that are able to help develop this, and that would be very interesting to see if that outperforms, the current silicone version. So this is definitely something that is going to be closely watched in the future. A lot of people are going to be skeptical and call this dystopian. A lot of people are going to call this a scientific advancement. I think we need a little bit more information before we see if, number one, this is very viable, very scalable, and then number three, if this is something that's actually going to take off. So this will be definitely an area that we're very curious to continue following and watching. If you are looking for an innovative and creative community of people using ChatGPT, you need to join our ChatGPT creators community. I'll drop a link in the description to this podcast. We'd love to see you there, where we share tips and tricks of what is working in ChatGPT. It's a lot easier than a podcast, as you can see screenshots, you can share and comment on things that are currently working. So if this sounds interesting to you, check out the link in the comment. We'd love to have you in the community. Thank you for tuning in to the AI Applied podcast. Make sure to rate this wherever you listen to your podcasts, and have a fantastic rest of your day.